Hello everyone, today we will talk about enhanced network slices. The objective of this video is to create a network slice where a NetApp can be deployed and to enable nodes to request and perform operations in IT Aveiro's network slices. Here we have a basic diagram explaining the workflow to create a network slice. As you can see, nodes will interact with the OSM to instantiate a VNF. This VNF will interact with the network slicing API and is able to perform actions to request a network slice, execute an action over the network slice, which in the example that will be soon demonstrated will be updating the downlink and uplink values, and finally tear down the network slice. All of these actions called by the API will be performed on the 5G core. Basically, it works as a wrapper to the 5G core. Now that you have an idea of how it works, let's see a concrete example. Going through an example of this workflow, the VNF that interacts with the 5G slicing API needs to be created. For that, we are creating a network service by clicking in the New NS button and filling the parameters. After it is created, we will go to Action and then Execute Primitive to request a network slice. You can check if it was correctly executed by clicking in the History of Operations. After it is completed, you can check the details of the operation. If you scroll down, you should be able to see the network slice details as it is shown here. Now we will create the NetApp that will be deployed on the requested network slice. Again, you just need to fill the parameters. Make sure that in the config descriptor, the Vim network name is the same as the one that was requested. After that, you can go to the VNF instances section and confirm that your NetApp is running in the requested network slice. Now, with your NetApp already running in the network slice, we will execute the actions mentioned before. Here, we are updating the uplink and downlink values to 1024 megabits per second. Once again, if you go to History of Operations, you can see the status of the request. Here, you can see that it was successfully updated. To test the values, we have a user equipment, as you can see on the bottom right corner, running iPerf with the VNF. As it is showing in the screen recording, the throughput values are going up as the uplink and downlink values were raised in the action previously performed. After that, we can change the uplink and downlink values to 1 megabit per second with the same procedure. And again, you can check that the values were successfully updated. Again, we are doing the same thing to test, using iPerf between the user equipment and the VNF. As expected, the throughput value is going down because of the previous action that reduced the uplink and downlink values. That is it for today. Hope you enjoyed and don't forget to follow us and check our community portal for more content. Thank you and see you on the next one.